In 2024, we made a decision that would take us in a completely new direction. We purchased a robot from Boston Dynamics, not as a novelty and not as a gimmick, but as a tool we believed could eventually change how we support the kids and families we work with. From the very beginning, the idea was simple. If technology and artificial intelligence are going to be part of the future, then we should be using them in ways that actually help kids thrive. To lead that effort, we put together a dedicated development team, headed by Natasha Reed. Their job wasn't just to experiment with what the robot could do, it was to figure out what it should do. How could this technology fit into real clinical environments? How could it support learning? How could it become something more than just a machine in the room? The answer was to start simple. Before Jarvis could help in serious ways, he had to learn how to interact, how to engage, how to play. So the very first thing the team decided to build was a game. A simple idea: hide and seek.
So what the game is supposed to do is it can interface with a client. We can have a kid or a person stand in front of it, and what it should do is choose a direction. So the kid can choose a random direction that it wants to go, left to right or center, and stay. And it will also choose a direction. If it finds you, meaning it chooses the same direction and sees you, it wins. So this was a breakthrough for us because it not only used his vision, recognition, and timer movements correctly, he maintained safety around all of the different objects we had in the room and around the different people that we had in the room.
When we first started building experiences with the robot that would eventually become Jarvis, we ran into a lot of challenges right away. The very first one was simple on paper, but complicated in reality. How do we even communicate with it? Pretty early on, we realized this wasn't just going to be a robot in the building. It needed an identity. It needed a purpose. That's when Jarvis got his name. And once that foundation was in place, we could start asking the more important questions. Like, how does Jarvis know when a person is standing in front of him? He needs to understand the world around him. He needs to recognize people. He needs to respond to them. So we taught Jarvis how to do exactly that, how to look at what he sees and determine whether there's a person there or not.
So we've had to train him how to see different objects. So now we're going to do the object training that we went through. You can see the output here. And then these are the different things he's captured. So what you'll see is this is what he's seeing. This is the mask that tells us if he sees the object. And right now you'll see it just keeps executing no, 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 because it doesn't see what it's supposed to see. So if I stand in front of it, hopefully it sees it. So now that we see the box around it, he knows that this is the object he's supposed to be looking for. So if I take it away, you'll see no, you don't see the object, you don't see the box. And then when I come back, he should be able to see the object. The reason for the box is to tell us that he's appropriately recognizing what he was trained to see. So that means if we teach it to recognize using machine learning, there are a plethora of things that he can learn. And then if he learns more than one object, he can learn to differentiate between objects. So if we have a cleanup protocol or like getting certain toys out, these are the kind of things that he can do. This one allowed us to use the imaging. That's an API system that basically has a world detection system to make sure that he has object permanence, basically. So the objects that are there when he moves and moves around. That allows him to maintain his navigational awareness so he doesn't trip over himself, and so that when he does approach an object, he can actually interact with it.
Teaching Jarvis how to recognize people and objects was just the first step. The next question was simple. How does he move through a space? The team started building a library of behaviors: walking, turning, lowering, bowing, even dancing. These movements can be triggered and looped, letting Jarvis exist in a space in a way that feels active and engaging. Right now, he can be guided from a tablet, almost like a video game. But that's not the goal. The goal is for these same movements to eventually run on their own, combined, sequenced, and triggered automatically.
So basically, we already had these pre-packaged functions, and a package is basically a cluster of functions that creates or recalls an action or a series of actions described by the SDK. And we use that to customize these actions so we can have our own actions to present. Now, it's important that we use some of the functions in the SDK because it accounts for things like balance, obstacle avoidance, and safety around our clients, around our users. With our autonomy for him, we made sure he had a library of movements that he could access when he wanted and how he wanted for a certain amount of time. And that allows us to provide him with autonomous navigation so he can move and act as he wants. Mission style behaviors, so when he executes a mission and he reaches an obstacle, this allows us to have him search through a library of actions to successfully navigate those interruptions. We also made sure to keep the safe stop, and this is just a time-based execution to make sure he doesn't continue to wander. See if it works. So I haven't done anything. Let's just see what he does. The best part is when we're at conventions or things like that, he can have access to these actions, so we can just stand beside him and he will move as he sees fit. We can also integrate our person recognition so that if he sees somebody, he can then, on that action, rely on a new library of actions. So if he sees someone, maybe he can tilt up, he can open and clap his little hand or his claw. So these are definitely actions we can combine to make custom interactions, to make sure he's always interacting with his environment appropriately, but continuously.
Anytime you're working with a robot like Jarvis, safety comes first. We have to think about balance, about pressure on the joints, about what happens if he shifts his weight or loses stability. The good news is a lot of that work is already built into the system. Jarvis is constantly counterbalancing himself in real time, adjusting, correcting, and keeping himself stable as he moves. That means we don't have to worry about him tipping over or putting himself in unsafe positions. It allows us to focus less on whether he can move safely and more on how he can move in ways that are useful, engaging, and reliable. And one of the things Natasha and the team realized was how much this actually changed the way people reacted to him. When Jarvis wasn't just standing still, when he was moving, bowing, even dancing a little, he felt less intimidating. People were more comfortable approaching him.
So we noticed that the positioning and the gaze played definitely a pivotal role in how people interacted with the robot, not because it itself had any aggressive stances, but because people perceived it in a certain way. So that was important for us to study, because in our settings that we want to use Jarvis in, he has to present as something trustworthy and safe. All right, so basically we're gonna run through to make sure that his language recognition is good. We wanted to start with visual recognition before we start with audio recognition, because Spot has more cameras than he does, and we had to create a custom listener in order to use audio recognition. So we're gonna start with the visual recognition. See if this detects that I've written something on here. It should say detect text. White. Good. Let's try another word. We'll do marker. See if it catches. Marker. Yep. So basically, we can use this recognition program. So this is actually the word recognition program. We have a different number recognition program. We can integrate them so that anytime Jarvis sees a certain word, maybe he can do a certain action. That'll help us. For instance, if he sees number 2, maybe we can make sure that he stomps for that amount of time. So he'll stomp 1, 2, so then we can do different pairing things, or that we can give him different commands when he gets to certain April tags. So if we put like, take a picture at this certain April tag, it'll be able to take a picture or observe audio in the room for a certain amount of time when it sees that, because of either the April tag, written verbal language, or numbers. And the best part about it being able to recognize both numbers and words is that when we begin to feed it data, it'll be able to take in the moment accurate data of an entire worksheet. So it won't just be 1 or 2 words. It can be an entire worksheet that we can encode, send it to a file, and then immediately upload that file. So a lot of times when we are at conventions or we are out with the local public, we make sure that we use the tablet a lot, simply because it allows us to do a lot of custom controls without having to rely on independent action. However, with us growing this work progression, we can make sure that autonomy can be integrated while using the tablet, so that if we do interact with people, because a lot of people ask us if he can wave, if he can, like, can he see me? Well, now we can make sure that our custom programs can be integrated into using it in the public with safety. It's also important to say that everything that we've created here are just our first demos, basically making sure we know that we have a good jumping off point for any direction that we want to take it. We wanted to make sure we use full capability of the robot with the ability to integrate the API, but making our own custom programs so that we can use it the way we want it. Because the way we're using it is a lot different than the way other people use it, which is more industrial settings. And so this has been a more dynamic view of the integration of technology and human behavior.
What Natasha and the team have built so far is really just the beginning. We're only starting to unlock what Jarvis is really capable of. Every behavior, every interaction, every small breakthrough is building towards something so much bigger. Something that can actually change how kids learn, how they engage, and how they experience the world around them. And it's only the beginning.